This is problem number 5. A rock is thrown with an initial velocity of 15 meters per second straight down from a treehouse that is 36 meters above the ground. How long does it take for the rock to reach the ground? I know I'm going y naught is 36, so I'm above the ground. My final position is 0. My initial velocity is negative 15 because I'm throwing it down. My a is negative 9.8. Since I don't have an acceleration, since I don't have a final velocity or time, I'm going to use the first equation. Notice 36 is my initial position, minus 15 is my initial velocity, my a is negative 9.8. Solve this, switch this around using symmetric property. I got negative 4.9 t squared minus 15 t plus 36. Yes, I could change that leading coefficient to positive because I like it to be positive. It doesn't really matter how you solve it. Since this is 0, it doesn't really matter. I'm going to let my a be negative 4.9, my b is negative 15, my c is plus 36. I substitute into the quadratic equation twice. First time with a plus, second time with a minus. I got a negative 4.64, then I got a 1.582. The negative 4.63 really doesn't apply because you can't have a negative time. Let's jump over the decimals and see what this looks like. I've already created 2 functions, but I'm going to create 1 function real quick. Let's hide that guy. I want you to see his point. Create a slider, create a function, hit play. We don't want that dot. Yeah, let's hide that purple dot for just a second. Notice I'm going to go back and change his domain. We want this range to be what? Let's call it about 6 on that slider. So now if I hit that slider, we're going to kill this slider, add that slider, come over here, let it go from where? 0 to 1.6, and let's do a step of what? Hundreds. So let's graph it now. Look how smooth it is. Boom. When it goes right past the 1.55, you know that's as far as it's going to go. It's going to increase speed, increase speed, increase speed, increase speed, and that's as far as it can go. Stop. Right? Now, we could force this to go one way. See, that way you can see what it's doing each time. It starts there, it goes farther, boom. Now, what happens if we didn't throw it? That means this function right here, gt, is going to be what? 0t. So what happens if we create another point to see? Obviously, it should take longer because we didn't throw it down. Alrighty, I'm going to do Control C. I'm going to come down here and paste it. Boom. Let's put that in G. Now you have that point. There it is in pink. So what would happen if we hit play? Notice how much slower it takes. Boom. What happens if we actually wanted to see how far it went? We can come over here and see it's about 2.7. So let's let this slider go out to about what? 2.7? Yeah. Now let's hit play and let's see what happens. Notice where it's at. It really, that's too fast. We'll slow it down, Mr. Smith. Really slow so you can see what's going on. There's the first one. Look what's going on. Since you throw it, he's going to get to the bottom what? Faster. This guy here takes a little longer to get there. Right? Now, let's get really crazy for a second. What happens if you threw it up? That means it's going to be a what? Plus, right? And notice what happened to that graph. Look how much longer it takes because it had to do what? Go up first. And there it is. Whee! Cool. Go back, make it negative. And now you can see the relationship between the two. Alright folks, sounds like a winner. Thanks. Love you, bless you.